Myself, Dr. T. BALASANKAR, Associate Professor, Chemistry Section, Faculty of Engineering Technology, ANNAMALAI University. So, in this lecture, I am going to discuss about polymer. It is a very important topic in the first year BE Chemistry curriculum. So, polymer is a macromolecules made by linking large number of small molecules. The small molecules are called monomer. So, large number of monomers are combined together in the presence of temperature pressure to form a bigger molecule is called polymer. The best example is the formation of polyethylene. So, the polyethylene is formed from the ethylene molecules. The molecular formula for ethylene is CH2 double bond CH2. N number of ethylene molecule is polymerized in the presence of temperature, pressure and catalyst to form a polyethylene. So, the ethylene molecule is the monomer CH2 double bond CH2 and the small molecules monomers are combined together to form a bigger molecule is called polyethylene. Another example is the formation of polystyrene. So, the polystyrene is formed from the styrene monomer. The molecular formula for styrene is CH2 double bond CH3CH5. So, it is combined with together in the presence of temperature, pressure and catalyst to form a bigger molecule is called polystyrene. Next example is the formation of polyvinyl chloride. In this polyvinyl chloride, the monomer is vinyl chloride. N number of vinyl chloride, the molecular formula is CH double bond CHCl, is in the presence of temperature, pressure and catalyst to form a polyvinyl chloride CH2 CHCl n numbers. Next example is the formation of polytetrafluoroethylene, or otherwise we called as Teflon. In this polymer, the monomer is tetrafluoroethylene. The molecular formula is CH double bond CH2. The tetrafluoroethylene is polymerized in the presence of temperature, pressure, catalyst to form a polytetrafluoroethylene. In this reaction, the reactant which contain double bond, when we convert into product, the double bond is converted into single bond, and in this reaction we put the N in the prefix in the reactant and we convert into product, the N we put in the suffix. So, next one is degree of polymerization. So, the degree of polymerization is defined as the number of repeating units which is present in the polymer reaction is called degree of polymerization. So, what is the value of N? The N may be 100 or 1000 or tens of thousand molecules. Normally, the polymer which contain 5000 to 2 lakhs molecular mass range. So, the number of repeating units, what is the value of N which is present in the polymer reaction is called degree of polymerization. Next one is called the nomenclature of polymer. So, polymers are classified into several types. So, the name of the polymer we can classify into several types. So, first one is called homopolymer, copolymer, linear homopolymer, branched homopolymer, linear copolymer, branched copolymer, like this. So, what is the homopolymer? So, the polymer which contain identical monomer, only one type of monomer which is involved in the polymer reaction is called homopolymer. For example, M is the monomer. So, the M, for example, ethylene molecule CH2 double bond CH2, the ethylene molecule only involved in the polymer reaction to form a polymer in this product which contain only ethylene molecule. Next one is called copolymer. So, the copolymer is defined as minimum 2 number of monomer which is involved in the polymer reaction to form a product is called copolymer. For example, 2 monomer, for example, ethylene molecule or vinyl chloride molecule. Ethylene molecule is the one monomer and vinyl chloride is the another monomer. Both the monomers are combined together in the presence of temperature, pressure and catalyst to form a polymer in the structure which contain M1, M2, M1, M2, M1, M2. So, M1 is the ethylene molecule and M2 is the vinyl chloride molecules. So, the homopolymer further classified into 2 types. One is called linear homopolymer and the second one is called branched chain homopolymer. In linear homopolymer, the monomer which is present in the polymer reaction in a long chain, only one chain, it is called a linear homopolymer. So, the monomer which is present M1, M like this. And second one is called branched chain homopolymer in the main chain which contain only one branch, but all the monomers are same monomer. This type of monomer is called branched chain homopolymer. And the next one is called linear copolymer. So in this linear copolymer, the two type of monomer which is present in a straight chain, it is called homo copolymer, M1, M2, M1, M2, M1, M2 like this. In this main chain which is contain different branches, it is called branched copolymer. And another example is M1, M1, 2, M1, M2, M1, M2 and the branch which is contain M1, M2 like this. Third one is called cross-linked copolymer. So in this cross-linked copolymer, the main chain which is contain lot of branches, it is called cross-linked homopolymer. Next one is called homo chain and hetero chain polymers. What is homo chain polymer? So the polymer which is contain only one type of atoms which is present in the main chain is called homo chain polymer. The main chain which is contain minimum two type of atoms which is present, it is called hetero chain polymer. For example, in polyethylene, the main chain which is contain only carbon is present in the main chain, it is called homo chain polymer. If the main chain which is contain different type of atoms which is present, it is called hetero chain polymer. The best example is nylon 6,6. In this nylon 6,6, the main chain which is contain carbon, carbon, nitrogen, oxygen like this, it is called hetero chain polymers. Next one is called functionality. So the functionality is defined as the number of bonding site or reacting site which is present in the monomer is called as functionality. Suppose only one type of function group which is present. For example, we take acetic acid. So in the acetic acid, the function group is COOH. So it is only one function group is present. It is called monofunctional monomer. For example, in ethyl molecule, there is no functional group which is present, but it contains double bond CH2 double bond CH2. The double bond act as a bifunctional. Another example is hexamethylene diamine, CH2 6 times NH2 NH2. The NH2 group is the functional group in this molecule which contain two NH group, so it is called a bifunctional group. Another example is adipic acid monomer. In adipic acid, the molecular formula is CH2 4 times COH COH. The function group is carboxylic acid group. In adipic acid which is contain two COH group, it is a bifunctional. So the number of bonding site or the number of reacting site which is present in the particular monomer is called functionality. It may be monofunctional monomer or difunctional monomer or trifunctional monomer. Next one is called type of polymerization. So based on the formation of polymer, we can classify into three types. First one is called addition or chain polymerization, and the second one is called condensation or step polymerization, and the third one is called copolymerization. First one is called addition or chain polymerization. So in this type of polymerization, only one type of monomer is involved in the polymer reaction to form a product. The product is exactly multiple of monomer and no byproducts are formed in this reaction. Such a type of reaction is called addition or chain polymerization. So in addition and chain polymerization, it satisfies three conditions. First condition is only one type of monomer is involved in the polymer reaction, and the second condition is the product is exactly multiple of monomer, and the third condition is no byproduct like HCl, H2O, methanol, ethanol are not formed. The best example is the formation of polyethylene. So in this polyethylene, the monomer is ethyl molecule. The molecular formula is CH double bond CH2. N number of ethylene molecule is polymerized in the presence of temperature, pressure and catalyst to form a polyethylene. The polyethylene product which is contained, what is the skeleton which is present in the monomer? The same skeleton which is present in the polymer also. CH2 CH2 groups are repeated, and in this reaction no byproducts are formed, and also only one type of monomer is involved in this polymer reaction. So another example is polypropylene. So the propylene molecule is the monomer. The molecular formula is CH3 CH double bond CH2 is polymerized in the presence of temperature, pressure and catalyst to form a polypropylene. So in this polymer reaction, only one type of monomer is involved in this reaction. The propylene is the monomer, and the product is exactly multiple of monomer. What is the skeleton which is present in the propylene? The same skeleton which is present in the product also, and no byproducts are formed. And another very important example is polyvinyl chloride. The molecular formula is CH2 double bond CHCl is polymerized in the presence of temperature, pressure and catalyst to form a polyvinyl chloride. All of you know the PVC. So, in this reaction only one type of monomer is involved in the polymer reaction. In this reaction the monomer is vinyl chloride. So, the vinyl chloride is polymerized in the presence of temperature, pressure and catalyst to form a polyvinyl chloride. The product is exactly multiple of monomer. So, the reactant or monomer which contains CH2 double bond CHCl, the same skeleton which is present in the product also, and no byproducts are formed in this reaction. This type of reaction is called addition or chain reaction. Another important example is formation of polystyrene. The molecular formula of styrene is C6H5CH double bond CH2. It is the monomer. It is undergo polymer reaction in the presence of temperature, pressure and catalyst to form a polystyrene molecule, and the product is exact multiple of monomer and no byproducts are formed in this reaction. And some more examples are there. Another one example is the formation of polyacrylonitrile. This polyacrylonitrile, the molecular formula is CH2 double bond CHCN, and which is undergo polymer reaction to form polyacrylonitrile. Next type of polymerization is called condensation or step polymerization, and condensation step polymerization is defined as the minimum two type of monomer is involved in the polymer reaction, and some byproducts are formed in this reaction. The byproducts are HCl, water, methanol or ethanol, and the product is not exactly multiple of monomer. So, the structure of the product is not exactly the monomer. The best example is the formation of nylon 6,6. In this formation of nylon 6,6, two monomers are involved in the polymer reaction. One monomer is hexamethylene diamine. The molecular formula is CH2 6 times NH2 NH2, and another monomer is adipic acid. The molecular formula is CH2 4 times COH COH. So, hexamethylene diamine is the one monomer and adipic acid is the another monomer. So, both the monomers are involved in the chemical reaction in the presence of temperature, pressure and catalyst to form a polymer is called nylon 6,6. The structure of nylon 6,6 is NH CH2 6 times NH CO CH2 4 times CO like this. So, this structure is repeated for the structure of the polymer. So, in this reaction two type of monomer is involved in the polymer reaction, and the byproduct is water is formed, and the product is not exactly multiple of monomer. So, condensation or step polymerization should satisfy three conditions. First condition is minimum two type of monomer is involved in the polymer reaction, and the product is not exactly multiple of monomer, and the third condition is the byproduct like water, HCl, methanol, ethanol are formed. So, another example for step polymerization or condensation polymerization is the formation of polyester. So, in polyester formation it contains two monomer. The one monomer is n number of ethylene glycol and another monomer is n number of terephthalic acid. So, both the monomer are involved in the polymer reaction in the presence of temperature, pressure and catalyst to form a product is called polyester. So, the molecular formula is polyester is OCH2 2 times OCO phenyl ring and CO n times. So, ethylene glycol is the one monomer and terephthalic acid is the another monomer. So, both the monomers involved in the polymer reaction in the presence of temperature, pressure and catalyst to form a polyester, and in this reaction the byproduct is water molecule and the product is not exactly multiple of monomer. And the third type of polymerization reaction is called copolymerization. In this copolymerization is undergo satisfy three conditions. The first condition is minimum two type of monomer is involved in the polymer reaction and no byproducts are formed in this reaction, and the product is not exactly multiple of monomer. So, in this best example is the formation of polybutadiene co-styrene or styrene butadiene rubber. So, in this polymer product are formed by reacting n number of butadiene molecule and n number of styrene molecule. So, butadiene molecular formula is CH double bond CH, CH double bond CH2. So, n number of butadiene and n number of styrene molecule are present in the reaction vessel in the presence of temperature, pressure and catalyst to form a polys butadiene co-styrene polymer. So, in this reaction the first condition is two type of monomer is involved in the polymer reaction and no byproducts are formed in this reaction. This type of reaction is called copolymerization. Next one is the differentiate between addition or condensation polymerization. So, in addition polymerization the repeating units are growth in the one time at the chain, but in the condensation polymerization the two molecule pieces are present in and both are react in both the direction. And second, addition polymerization the number of units are decreases steadily throughout the reaction, and in condensation polymerization monomer disappear early in the reaction. So, all the monomers are involved in the chemical reaction. In addition polymerization the products are high molecular mass polymers are formed. In condensation polymerization the molecular mass are rises steadily throughout the reaction, and in addition polymerization longer time reaction times are little effect on molecular weight but gives high yield, but in condensation polymerization to obtain high molecular weight longer reaction times are essential. And in addition polymerization normally the polymers ranges of 10 to the minus 8 parts of growing chain, and all type of molecular species are present in any stage in the condensation polymerization. It is the difference between addition or condensation polymerization. Next one is the mechanism of addition polymerization, how the polymer reactions are formed. So, in this mechanism which contain three important steps, the first step is chain initiation steps, and the second step is chain propagation, and the third step is chain termination steps. In chain initiation steps containing two reactions are involved in the chain initiation steps. The first reaction is the formation of free radical. So, any chemical reaction is involved in the reaction vessel, we need one catalyst. So, in the polymer reaction we use catalyst hydrogen peroxide or benzyl peroxide. The first step is the benzyl peroxide or hydrogen peroxides are homolytically cleaved and to form a free radical. So, I is the initiator. So, the I may be hydrogen peroxide or benzyl peroxide. So, it can be cleaved in homolytically to form a free radical. We donate a symbol R. The next reaction in the chain initiation step is the free radical is first react the monomer which is present in the reaction vessel. So, only one monomer is attacked in this free radical to form a monomer free radical. For example, R is the free radical and any molecules, monomer molecules CH double bond CHY. Y may be hydrogen, it is called ethylene. Y may be Cl, it is called vinyl chloride. Y may be phenyl ring, it is called styrene. Y may be cyanide, it is called acrylonitrile. So, the free radical first attack only one monomer which is present in the reaction vessel to form a monomer free radical. So, the monomer free radical is the highly reacting species which is combined with another monomer which is present in the reaction vessel. It is called chain propagation steps. So, the second step is called propagation steps. In this propagation steps the monomer free radical is react with another monomer and the formed new monomer free radical combined with another monomer. So, all the monomer which is present in the reaction vessel are combined to form a long chain, and in this long chain the last monomer which is contained the free radical. So, the following reaction is very easy to understand. M1 is the free radical, it combined with another monomer to form a M2 is the another free radical. The M2 free radical is combined with another monomer which is present in the reaction vessel to form a M3 is the another monomer polymer free radical. So, these all the monomers are combined and to form a long chain, and finally no more monomer which is present in the reaction vessel, and this long chain which is contained a free radical in the last monomer. And the third step is called chain termination steps. In this chain termination steps, the monomer which is contain a free radical, or the polymer chain which is contain the free radical in the last monomer, these two monomers are combined to form a long chain. This is the one type of combination in the termination steps. And the second combination is one monomer which is contain the free radical in the last molecule. Similarly, the free radical which is contained in another monomer in the polymer chain, and the bond rearrangements are taking place, and to form a two type of product, one is called saturated compound and one is called unsaturated compound, which is present in the reaction vessel. So, this is the termination steps. First step is called two monomer molecules are combined, polymer molecule which is contain a free radical in the last chain. So, both the polymer units are combined to form a long chain, and another one is called two molecules are combined, one molecule containing saturated compound and another molecule containing is called unsaturated compound. Next one is called plastics. So, plastics is the high molecular weight polymer which can be molded any shape and size. So, this can be divided into two types. One is called thermoplastic resin and another one is called thermosetting resins. What is thermoplastic resin? So, thermoplastic resin is defined as it is a high molecular weight polymer. These polymers can be molded any shape and size and it can be reused. This type of plastic is called thermoplastics. The best example is polyethylene, polystyrene, polyvinyl chloride, all these plastics. And another one is called thermosetting polymers. In thermosetting polymer is a high molecular weight polymer which can be molded any shape and size. So, once they can be formed, it is permanently formed, it cannot be remolded. This type of polymer is called thermosetting polymers. So, the difference between thermoplastic and thermosetting, and thermoplastics are soften on heating readily. So, when we apply the heat, the polymers are very soft, and back to the normal temperature, these polymers are very hard. But in thermosetting polymers, they do not soften on heating, but prolonged heating they can be burned or it can be broken. In thermoplastics, they are long chain linear macromolecules, but in thermosetting polymer, it is a three-dimensional network structure and all the structures are combined with covalent bond. In thermoplastics, they are formed mostly by addition polymerization. In thermosetting, they are formed by condensation polymerization. And these thermoplastics are heating, they can be get softened, and it can be by cooling in the normal temperature, it can be hardened. But in this thermosetting, they are not retain this shape and structure in the heating. So, they are usually soft, weak and less brittle in the thermoplastic polymers, but in thermosetting polymers they are usually hard, strong and more brittle. And thermoplastics are reclaimed or reused from the waste, but in thermosetting it cannot be reclaimed from the waste. And thermoplastic polymers are usually soluble in some organic solvents like benzene, chloroform like this, but in thermosetting polymers it is chemically inert, it cannot be soluble in organic solvent, benzene, chloroform like this. So, next one is called preparation, properties and uses of some important polymers. So, in this topic, the important thermoplastics polymers are polyethylene, polystyrene, polyvinyl chloride, nylon 6,6, and its preparation, properties and uses are we are going to discuss. First one is called polyethylene. So, the polyethylene is formed from the ethylene molecule. We know the molecular formula of ethylene molecule is CH double bond CH2. So, the ethylene molecule are polymerized in the presence of temperature pressure catalyst to form a polyethylene. So, this polyethylene normally two types of polyethylenes are formed by using the catalyst we are using in this reaction. One is called low density polyethylene. By using the free radical mechanism or free radical initiator or free radical catalyst, hydrogen peroxide, benzoyl peroxide, we synthesized low density polyethylene. By using the ionic catalyst, we prepared high density polyethylene. So the uses of polyethylene is that it is the mainly used for insulated parts, and it is also used for the manufacturing of bottle caps, flexible bottles, kitchen and domestic appliances, and toys, sheets, packing materials, pipes and coated wires and cable bags or packing bags are used by using the polyethylene. So next one is very important, all of you know, the polyvinyl chloride, PVC. So the polyvinyl chloride is synthesized from vinyl chloride. So the vinyl chloride molecular formula is CH double bond CHCl. Vinyl chloride undergo polymerization in the presence of temperature, pressure and catalyst to form a polyvinyl chloride. So the polyvinyl chloride is synthesized from the vinyl chloride, and this vinyl chloride is synthesized from acetylene molecule. So acetylene is undergo react with hydrochloric acid in the presence of catalyst normally by using the metal catalyst, and the temperature is maintained around 60 to 80 degrees centigrade to form a vinyl chloride. So the vinyl chloride is undergo polymer reaction to form a polyvinyl chloride. The polyvinyl chloride is synthesis normally two types. One is called rigid PVC or unplasticized PVC, and the second one is called plasticized PVC. By using the catalyst, different catalysts, we can synthesize different type of PVC, rigid PVC and plasticized PVC. So this rigid PVC can be used for making the sheets, and it is also used in the tank lining, light fitting, safety helmets, refrigerated component, tire, cycle and motorcycle mudguards are used by using this rigid PVC. And the plasticized PVC is the more plastic nature, which is it is used for packing of raincoats, tablecloth, curtains, electric insulation like a covering of electric cables, injection molding articles like toys, the manufacturing of toys and tool handles are synthesized by using the plasticized PVC. So next one is called the preparation of polystyrene. So the polystyrene is a very important polymer. It is synthesized from the styrene molecule. So the molecular formula of styrene is CH2 double bond CH6H5, which is undergo polymer reaction by addition polymerization by using the catalyst hydrogen peroxide or benzyl peroxide, and to form a product is polystyrene. And this styrene molecule is synthesized from ethylene molecule. So ethylene undergo react with the benzene to form ethyl benzene. First step is the formation of ethyl benzene, and undergo further reaction with aluminum chloride acts as a catalyst to form a styrene molecule. So the styrene mainly used for polystyrene mainly used for to molding the article like toys, combs, buttons, radio and television parts are synthesized by using this polystyrene. Next important polymer is called nylon 6,6. The nylon 6,6 are formed by condensation polymerization. This nylon 6,6 is synthesized from two monomer. One monomer is called hexamethylene diamine and another monomer is called adipic acid. N number of hexamethylene diamine and N number of adipic acid is undergo polymerization by using the catalyst, temperature and pressure to form a nylon 6,6. So the hexamethylene diamine, the molecular formula is CH2 6 times and NH2 and NH2, and adipic acid, the molecular formula is CH2 4 times COH and COH. The first step is one monomer of hexamethylene diamine, and that is one molecule of hexamethylene diamine and one molecule of adipic acid is undergo polymerization, and the hydrogen from NH group and OH from adipic acid is involved in the chemical reaction to form a new bond with removal of water molecule to form a product. The second step is the hexamethylene diamine containing two NH group, and one NH group is first involved in the polymer reaction. Similarly, in adipic acid two COH groups are present. One COH group is involved in the polymer reaction to form a one product. The newly formed product which contain NH group in the left hand side free and COH group is free in the right hand side. So, lot of monomer which is present in the reaction vessel is undergo further condensation reaction with another monomer and removal of H2 molecule in both the direction, and finally all the monomer is involved in the polymer reaction. No more monomer which is involved in the reaction vessel. Finally, we get a long chain. It is called nylon 6,6. The structure is NH CH2 6 times, NH CO, CH2 4 times, and CO. So, these molecules are repeated in the nylon 6,6 structure. So, nylon 6,6 are used for mainly used for the undergarments and dresses, carpet, or manufacturing by using nylon 6,6. It is also used for the toothbrush films, tire cords, or manufactured by using nylon 6,6. So, another important polymer is bakelite. So, the bakelite is the important thermosetting polymers. So, this is the bakelite is the formed by using the phenol. So, phenol is the starting material. So, the first step is the formation of mono, di and trimethyl phenol. So, phenol undergo react with formaldehyde to form a monomethyl phenol. Phenol is react with 2 molecule of formaldehyde to form dimethyl phenol, and phenol react with the 3 molecule of formaldehyde to form trimethyl phenol. The first step is the formation of mono, di and trimethyl phenol. The phenol is react with only 1 molecule of formaldehyde, it form monomethyl phenol or ortho-hydroxymethyl phenol and para-hydroxymethyl phenol. 2 products are formed when phenol is react with formaldehyde. Suppose the phenol is react with 2 molecule of formaldehyde to form dimethyl phenol, and phenol is react with 3 molecule of formaldehyde to form trimethyl phenol. And the second step is the formation of novolec. So, the novolec are formed or synthesized by using the monomethyl phenol. The monomethyl phenol which contain OH group and adjacent to CH2 OH group and react with phenol. So, the phenol which contains C6H5OH and adjacent to OH group one hydrogen is there. So, it is involved in the condensation reaction with removal of water molecule and to form a long chain. The structure of novolec is there, C6H5OH CH2 CH2. So, methyl linkage which is present in between 2 OH group, phenol group, and this is the structure of bakelite. The monomethyl phenol, novolec and resols are combined and to form a structure is called novolec. This is the structure of bakelite. This is the structure of bakelite. So, the uses of bakelite. So, bakelite is mainly used for the electrical insulator parts like switches, plugs, switchboards, heater handles, or manufacturing by using the bakelite. And also it is used for the molded article, telephone parts, cabinet, radio and television cabinets are manufacturing by using this bakelite. And it is also using the some bearings. It is used for the paper indices and rolling mills or manufacturing by using this bakelite. In this topic, we discussed about what is the polymer and different type of polymers and nomenclature of polymers and how the polymer reactions are formed by using the chain polymerization, condensation polymerization and copolymerization. And also we discussed the different type of plastics, what is thermoplastics and important thermoplastics synthesis, properties and uses. And also we discussed about the important thermosetting polymers and its preparation, properties and uses. Okay, thank you.